Yeah, okay. So I guess the other thing, other than stress testing, that I was talking about is looking through the race condition reports. I guess this is going to be quite interesting to an extent. You know, in a full round of testing, I mean, the race condition report goes into about 4,000 lines. Let's just see if we can identify what the race conditions are. What is it complaining about? Well, let's look at a few examples. So, for starters, we have. I'm trying to figure out what order this dump is in. So when it says await election, oh yeah, init follower called await election, and then init follower was called by something else. Um, I know await election always follows init follower, so I'm thinking this is the latest function, and then this is the function that called that, and then this is where the go routine first started. You know, go routine, go run init, so common.go in line 16. This will confirm what I'm saying. That function, you know, rf.initFollower, was run concurrently, and that's how this began, right? So I think the -fm means that's what was run in the first place to get this go routine, and then it's like, okay, it ran initFollower, then it ran await election, and so it's line 31 of await election is one of the things where we have a race condition. Vote count, okay? So this is writing to vote count here. I guess it's defining vote count. But then we have a read of a different go routine running follower code in line 22. Is it the same routine? No, this is go routine 9. And then it says like go routine 14 created that, go routine 9 created that. So we have a bit of information. Phase change, which was called by make. So it's at the very beginning, start, you know, the tester. I mean, same thing happened to this one. You know, start in the tester, ran Raft, and then make, and it starts with a separate go routine. So it's probably, what this probably is I don't know, a clash between different. So let me just quickly, because I haven't checked in a while, check that I'm still live. Move the camera a little bit. Budge it down, Live, camera, mic, sick. So I'm just trying to identify what's going on here. What is the race condition detector talking about? And so I think from when it says, you know, these go routines were created as follows, born by fire. I mean, it just starts up. You can see that this is basically identical. It just starts up the same code. I can't figure it out if this is representing different servers. Oh shit, that's why the laptop's overheating. Fan was in the wrong place. I'm so stupid. I'm an idiot. Yeah, laptop fan's been going, but my external fan was actually going over the top of it because I forgot to move it when I sat down like an hour ago. So stupid. Such a dum-dum. Hopefully that'll chill out. It'll just come down to about 60 degrees, I think. I don't know. Maybe it'll stick around 70. So yeah, we have two different go routines, but we can't figure out which server is which between these two go routines, I feel. It says, you know, previous read by go routine, but then there's a write by a go routine, and the read is... Oh, actually, it's the follower code, not the candidate code. Sorry, I'm an idiot again. So many mistakes in such a short span of time. So a read from 31 and a write... a write in 31 and there was previously a read in 22. So the write is the election timeout, which is outside of the lock, and the read is 22, did we say? Yep, so this is about the election timeout variable. You know, two different Go routines seem to be editing my own election timeout. So I wonder why that is, considering there should only be ever be one await election active at a time. Don't know how that's managed to happen. But I mean, election timeout is always just getting set to steady election timeouts. You know, except at the very first run, in which case it's not. So I don't know about that. If that's even worth fixing, because it just always gets set to the same number, namely this steady election timeout constant. So something read it, but something else set it. I don't know how that happened though, because it's, you know, we're working within one server, one instance. So there should only be one copy of await election active. And this is, yeah, it's not helping me figure out how they got created. Start one. But it's like, are you sure that these are not just two different servers, and so they have different election timeout variables? Should I, to guarantee that this is working fine, assign election timeout to RF, just for the avoidance of doubt in the tester? I guess I may as well do that, because within the code I'm editing this variable, so yeah, why not just do that? There's absolutely I think there's no cost to doing that. I'm just gonna, you know, set selection timeout as follows, go to the definition. Well, I mean, I can't do that because I edited it, but I can scroll up here and just say rf.election timeout equals 0 initially. This is all just a bunch of constants. I may as well just identify them as follows. Then yeah, we have the election reset thing. And then yeah, just in the make function, I may as well just set the initialization codes, you know, just election timeouts is 0. Okay, why does that cause a problem? Oh, type Raft has no field or method election timeouts. Okay, well, I don't particularly care. I may as well just dump that in. Yeah, election timeout is going to have type time.duration. That should do it. Why are there now 19 problems? Oh, undefined election timeout. Yeah, so now it just reads from the Raft object to get the timeouts. Which means in principle moving this before here, whoops, or rather moving the lock until after the timeout is set, which is not going to change anything major, I don't think. It's just, you know, timeout is literally just a variable that's set, so I'm not actually doing anything here, I'm just calculating a timeout. So, I do a random integer calculation. This is all very fast, so it's not going to lag the program, I don't think. Then it'll do, time.duration, just converts that into a type and just saves it to timeout. And then this is where the actual waiting and whatnot happens. And so it's not a big deal. It's just, yeah, this is slightly sketchy. Setting it here could, cause a... Have I fixed anything by doing this? I'm still gonna get that race condition because I'm not doing it here. Oh wait, but I can just do this. I read the timeout the very first time, and then I just set the timeouts in the same breath, pretty much, to steady election timeout, and I do that in the lock before I start waiting. Fine, yeah, that works. This way there should be no, because it's within the lock, so it's automatically gonna. I didn't even have to attach it, did I? I could have just read it and set it here. But yeah, whatever. It's just such a minor difference. I'm not gonna revert it. I guess yeah. I could have just read and set it all within the lock, and that would have fixed it. Okay, whatever. That's really such a minor thing. Okay, fine. So cool. Race happened there. Then this test managed to fail of its own accord without a race condition being detected. That's dodgy. That's not happened before. God. This is a test that, for reference, passed like 200 times in a row, but failed occasionally when I changed my testing setup to not block programs between tests. But then I came up with an alternative way of doing that, and that seems to be working, but now it seems to have failed, which is unfortunate. It's not a big deal. So then, yeah, it doesn't detect any race conditions until here, where start clashes with heartbeats. No, it doesn't. Yeah, no, it does. Start clashes with heartbeats. So Raft, line 169, which is about the log getting appended to, which happens within the log. Like, clearly that's happening within the log. Clashes with heartbeat line 43 in the leader code, which asynchronously reads the length of the log without taking the log. Huh. What have I done here? That's quite sketchy, isn't it? Oh, shit. Yeah, that's something that I broke and then failed to fix. Okay, let's fix it now. This should at least be easy. I'll explain in a sec what's going on, by the way. Let me just, move my camera up because I moved position again. Cool. Should I bother refocusing the camera? Yeah, let's do it. Let's refocus later. Yeah, I'm just going to go with good enough when it comes to refocusing. Otherwise, yeah, camera's still working on stream, mic. Yep, and live. Can't believe I'm going into 2 hours here. But yeah, I'd forgotten about things like race conditions, and I'm just dynamically going around fixing things one after another. It's going to be hell to split this up into VODs, but I'm so close to the end of the project that it doesn't matter. Basically, this stuff used to be synchronous, and so it was within the lock. It's no longer synchronous, which is a problem. So, here I'm accessing data. All I'm doing is like accessing the length of the log and, oh yeah, other things as well, like current term, commit index, all this stuff. Is being done within this asynchronous function. Okay. Well, I'm trying to remember why this was an asynchronous function in the first place. This is the leader sending heartbeats out. You know, it's saying like, I read off my own next index, my own arguments, all of this stuff, and it just all happens outside the log. All of it is reads, but nonetheless, it's not good to do that outside log, realistically. So how do I fix that, actually? I say it's easy to fix because I think, you know, most of this stuff I can just pretty much calculate out ahead of time individually without. Why did I actually come to the conclusion that I should be defining arguments separately? Sorry, yeah, you know, repeatedly defining it every time I send out a new heartbeat. That feels like a decision I wouldn't have made. I don't know why I've done that. Is it that this used to be synchronous? Because it's definitely not synchronous anymore. The sending of heartbeats. Well, the sending of heartbeats should not be synchronous, I don't think. But I don't know. It's weird. I mean, surely what I should be doing. I love my last index, which has to be defined here in order for it to work. Yet gets used down here, and I never figured out why that is as well. I feel like, you know, that's the thing. If I change this, it could easily lead to a lot of trouble. Yeah, there are your race conditions, I guess. I mean, I can kind of understand why I'm, you know, defining all this stuff asynchronously, because but I guess I can still do it synchronously just outside the go routine. Maybe it's asynchronous for performance reasons. I don't know. Listen, let's just. I'm just gonna, because it violates my race condition convention that, you know, I do after all want all accesses, all reads and writes of state variables to be done within locks. That's just a principle that I've been pushing from day, right? From day. And so the fact that I've accidentally violated it, I'm just going to fix that. I mean, the naive, easy way of fixing it is to just do this, to be honest. But then why, you know, why was this ever like this? I don't understand. If I do this change, it's quite a significant change. Will the test still pass? Um, wow, I'm getting undefined election timeouts in my tester. Yeah, I've made a bunch of changes now, and I need to make sure I don't get snowed in with changes. Yeah, one change at a time. Don't introduce excess bugs. So yeah, I mean, I've introduced some crash bugs, just to do with this election timeout number, which I'm getting bugs left, right, and center now. I'm sort of starting to walk into trouble. Perhaps I've been just too brazen with making changes. I think that might be, you know, the explanation of my woes here. But you see, other than that, it seems to be passing. It's just when it says undefined election timeout, follower go 22. No, but this has been fixed though, so maybe it was just running the test with the code not saved. Hopefully that's what happened there. Yeah. I'm going to revert it. I'm not comfortable with this. I'm going to reverse it so that, election timeout is not part of the Raft object. Instead, it's just a thing that is a variable that is just set within a lock, obviously. So hopefully I haven't messed things up too much for this to start to be a problem. So yeah, just scroll to the top and put it back to how it was, more or less, except this is a variable. Well, yeah, it's basically the same as it was, except when it gets accessed in the follower. I think the follower is the only one that cares. Then it's election timeout. It's not a part of the RF object anymore. But it's also within the lock now, so that's all good. So yeah, the 2B tests should still be passing fine, I think. Because that election timeout code is just so fundamental. It's run at the beginning of every instance. Every instance of Raft, and it determines the election timeout, which governs all of these tests, and so yeah, that's got to be working fine. It is still working fine, thankfully. That little change there. Well, okay, now that that's working okay, I'm gonna make the edits to how arguments are done here. So surely I can just do go send append entries with ID. Why is this being set concurrently? I think that was just my attempt at optimizing something that didn't work out. So now it's all back within the lock, and hopefully it'll just pass again without any problems. I think the 2B tests are the ones that will sort of determine if this works or not. Has it slowed anything down? Is it working the same? It seems to be not caching anything, I hope. Yeah, because the times are different. So yeah, I think it's working fine again. And so I don't have to nest this within a function. I can just call this straight off now. I don't remember why I made that change. It was just, I guess, such a long time ago. Well, with that change done, I'm just gonna straight up, just run the full test in the console. Hope it works. If it works once, it's probably solved any qualitative error that was there. I don't know if it's caused a slowdown in performance. Hopefully not. Performance vs debugging race conditions. My hope is that race conditions are what cause problems. That if I fix that, then it'll just be more reliable in general, fundamentally dealing with the worst of it, rather than thinking about how having a race condition might improve the performance. It's probably for the best to cut them all out. Let's scroll to the next one while we're waiting for this to test. The next race condition. Lol, the fucking stack trace here is just an infinite line of heartbeats. Indeed. Fine, okay, we have another race here. Is it again start 169? So yeah, accessing the log. And that clashing with the heartbeats at line 43. Which has changed now, but I think that was the cause of most of the race conditions, probably. All of the ones that just have like an infinite list of heartbeats. It's probably it, yeah. And what else? Here we have, again, 169 and 43, and if all of them are just like that. Oh, here we have a different one. Oh no, sorry, I'm looking at the go routine number. Yeah, so it's just all 169 and 43. And a stack of heartbeats. It's quite funny seeing that. This is different. Okay, this is leader in line 40, clashes with common in line 47. Let's see if we can figure out what's going on there. So leader in line 40, I don't know what that is anymore because I edited it. Common in line 47. So rf.current term is getting set here. Within the log, I might add. But I think current term was getting read outside the log. But that's fair enough because all of this stuff was, yeah, okay. I think this is going to get rid of almost all of the race conditions, to be honest. I think most of them were coming from the fact that the leader was reading outside of the lock, which is a bug I guess I just didn't notice. Something I tried to optimize, make it faster by making it asynchronous, but it required the lock, so that was a mistake. Probably shouldn't have tried that in the first place. Well, you know how these things happen, to be honest. Camera, mic, live. Well, we had a pass here, so I think it's all good. Yep, I'm going to discard all of this race condition stuff and do it again, basically. Go test race. That'll take another 3 minutes. And then we'll see where we are with all that shit, I guess. I don't know. Other than that, I'm just going to do the stress test the way I said I would do it. Just repeat the full series of tests 200 times. We're going to get timings if it passes. We're going to get a full dump of the entire testing process, the entire iteration of the testing if it fails. But that's fine because I can just filter it out to pick out the exact test that fails. That's not a big deal. Because even if one of the tests fails, it runs all the other tests still, and so we'll be able to kind of pretend that we were running the test individually, if you see what I mean. So I'm completely down. I'm completely down with doing that. Yeah, all good. Yeah, okay. So I guess I'm saying, the next session is going to be question mark, question mark, question mark. Next session is actually going to be let me get this right. I'm not going to do it immediately in 24 hours because I want to give myself enough time to run the full testing get up. And also just let my subconscious figure out what the most efficient way of reliability testing is, because I tend to keep changing my mind if I do sessions too frequently, I think. So that's what I'm going to do. I'm going to say, like, okay, Thursday. I'm going to do another session. I'll do another evening session. It's just easier for me. I don't have to worry less about rescheduling. So it's going to be Thursday at 9 PM. I'm going to do another sesh. May as well just edit Streamlabs to say that. So I said ... because I thought this would be the last session, but my ability to predict things is awful. I'm not going to lie. So fuck it. Thursday 9 PM it is. Not a big deal. There are not going to be many sessions left. I'm just doing reliability debugging, getting rid of race conditions and such. And just basically my hope is that I can basically pass the individual tests 90% of the time plus. And my code runs in about 3 minutes, which is cool. Faster than it was. Yeah. MIT's example code, how fast does that run? This is just test 2C, so that's 2 minutes. But the full test, it doesn't say actually. But if you add these numbers together, so it's like 124 seconds plus 38 seconds is 150, 162 plus these tests, which are 7, so it's 169 to 171, allowing for rounding error. Get the moth out. Before, yeah, if I don't remove the moth, it will just probably get chopped by the fan. It's a really small moth. Not very nice to look at. So, do we have any race conditions? We have a few. We have many fewer than we used to, which is an improvement. Should we try to get rid of them? Okay, so await election, the follower line 21 and the follower line 22 are somehow clashing again. How in the fuck is that possible? This variable is getting synchronously edited. Look at this. Follower line 21, follower line 22. It's the same thing that we just tried to fix, except it's getting edited synchronously within a lock. I am bamboozled. How the hell is that a race condition? You know, it reads a variable and then it sets it to something else immediately afterwards. That's not a race condition. That's just normal synchronous code execution. What the fuck? What a joke. This thing is jipping me. Is that the only race condition? Yeah. There's another one here. Okay, let's have a look at this. Request vote, line 40, clashes with call election, line 38. So candidate line 38, request vote, line 40. Candidate line 38 is all about setting voted for. Is this not done inside the lock? No, yeah, because voted for, I edit it here just for the reason of when I vote for myself, I have to set voted for to be myself. Yes, that's true that I have to do that, but there's no reason I have to do that in this line of code. I can do it somewhere else. I can do it earlier. I can set this basically before I set up the vote. So here. So where voted for is set to -1. Why don't I, instead of setting voted for to -1, why don't I just set it to myself and then auto vote true? If I've incremented term because I'm starting an election, let's say I just immediately vote for myself. How much time passes between my incrementing the term and then deciding that I voted for myself? Answer, I define some boilerplate here and then send out a bunch of votes asynchronously. So it's not a lot of time. So I think I'm safe to just do that. So basically I'm going to move this as well as the persister. I'm moving them out and I'm moving them here. So basically what I'm saying is I don't need to... It's fair enough if I increase my term, it's fair enough that I reset who I voted for. But if the reason I increased my term is because I started an election, then it's a fair assumption I'm voting for myself. So I can just also set that to myself, and I can auto persist as well at the beginning of the election, which actually is kind of two birds, one stone, because this persistence was covering the increments in current term as well, because this was always happening after that. And so they were getting persisted once. That was kind of like an optimization I did. You can see it in my scrap notes, where I'm looking at when to persist. You know, new election edits current term, but it also edits voted for. Candidate voting for self is now the same as new election. So it's just like, okay, this is now getting persisted. And as you can see, term sync, I'm pretty sure, persists everything and all this stuff as well. So now absolutely everything is getting persisted. Settled. Yep, so that's a very easy and fast way of avoiding that particular problem. Do we have any other races at all? Past. Yeah, no, we don't. So those are the only races. One of them is this, which no idea, truly no idea. It's a minor thing, but I want the election reset timeout to be 0 at the beginning, just so that I can get the program working ASAP, get a leader going in the beginning ASAP. Because this thing, the tester will spam it with new input data. So I may as well try to at least get the leader elected as soon as possible. without too much spamming happening. Just makes it a bit more likely to work, I guess. But then it's fair enough, like it runs once and then it gets set to something else. So why this is happening, I mean, I have no idea. You know, I set a timeout variable as the follower. I set a timeout variable. Okay, yeah, that's a good point. I may as well run the full test suite to make sure I haven't messed something up while I think about this. You know, I set the timeout here synchronously and then read the timeout as well. So it's like election timeout is read and then it sets immediately afterwards. There's no way that that's a race condition because these two lines of code get executed one after the other. This is not going to fool me into thinking that this is a race condition. It's just like, what? Oh god, I'm getting failures in test 2B, unfortunately. You know, agreement despite follower disconnection is less reliable than it used to be. And I think that might be because of the change in the testing setup. I don't imagine that that's because of the edits that I've made now. Although it's hard to know when you're trying to fix many different problems at the same time. It's hard to know if one of your fixes doesn't break something else. All the tests seem to be more or less passing now all the time, except, you know, this one and possibly the one before it. Honestly, how to deal with that, I think possibly I might just need to put in ending lag. Every time an instance exits, I just implement a lag of a few seconds. It'll slow it down a bit, but it will at least make it more reliable, so I don't end up looking at this shit. Because I can run this test a million times, and it will just continue passing if I just run it by itself, and that's the evidence that you need that this is being caused by that little problem with the testing setup. Bearing all these problems in mind, man. It's a bit ridiculous, isn't it? Oh, that's just how it goes, I guess. It's past midnight, I'm about to stop for the day. But I want to stop in a position where I can do off-stream iterated testing and then come back and analyze the results on stream. So I guess I've gotten all of those race conditions settled except for that mystery comedy race condition, which I could not tell you about in the slightest. But I don't know. Okay, well this is about to finish in 5 seconds. 1, 2, 3, 4 seconds. 180 seconds total. Yeah, that one test is continually failing. But yeah, I'm just going to demonstrate now. If I run that test a million times, one after the other, it will work. So it's test fail, yeah, test basic agree. Now my numbering is gone. Re-election, okay. Test basic agree, test fail agree. Go. Fuck off. Why did that require 2 undos? I literally just typed something one line after the other. Yeah, see, I'll just run this exact command a million times and you'll see that it's the only reason it's failing is because of the tester leaking information. How many times is enough times for me to demonstrate this? Maybe I should stress test it individually. Well, I would say enough times is 15 on the trot. But like I said, what I'm gonna do, because I now have that debugger, I can edit the command that I'm running a million times. Currently it's just go test, but I can edit it to anything else. And so I can still sequentially run this test a million times if I wanted to. All I have to do is edit the thing, and I can do that off stream. That's fine. I'll let you guys know next stream, next sesh, Thursday at 9 p.m. British summertime. I'll let you know which tests I ran and what information was gleaned from said tests. Basically, I'll just bring it and present it to you guys. It'll pass a million times. So maybe I just need to introduce like that small timeout between tests to make it more reliable. It's a thing that I previously had in my testing setup. You know, if you look up kill, I've deleted it now, but I used to have just time.sleep after doing the exits. So the kill routine then just sleeps, and you know, before the next instance of the test is run, basically, I can just sleep for 200 times time.milliseconds. And that'll it'll just give it a grace period to allow it to try to run this exit. You know, because it can't force close things directly, it just has to signal a closure and wait for it to happen. And so hopefully that will allow that to happen and pass the tests enough times. But yeah, I mean, just look at this. Pass, 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 pass. I never thought I would be streaming this in my life. Pass, 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 pass. And this is the previous thing that failed. So yeah, it passed, I lost count, 20 at least. 20 times, which is what I mean, it just fails sometimes. It just fails sometimes purely because it's being run with the other tests rather than individually, which I'm trying to avoid as best I can. We'll see how it goes. We'll do the stress test with the current setup. So I am now running a small grace period between tests. And I am just lightly signaling to exit rather than locking, which froze the last two tests. It froze the last two tests, but it meant that I could do the full test for everything else, one after the other, with it working every time for that test that sometimes fails in situations where you are running tests sequentially like that rather than just the one test many times. So yeah, it's just that. It's just a bunch of stuff. I'm happy that I've fixed everything up now. I've removed all those race conditions. I didn't realize they were there. It's good that I checked that. So I'm happy to just do the stress test and see what happens. I'll wait for this to come through. It's, you know, again, it takes 3 minutes to run the full set of tests, and then I'll just have a look at the race file and see if that stupid race condition that's detected at the beginning is the only one, or if there are any others that are genuine things. Because I think that one I'm just going to leave it there as a warning that I can't be bothered to fix because it's just so stupid. Synchronous code triggering a race condition, it makes no sense. There's definitely something I'm missing there. Yep, anyway, that's it. That's it for today. I think. I'm just assuming that's the only thing that's going to crop up here because everything else is fixed, I'm pretty sure. But assuming that that is the case, thanks for stopping by. No chat recently, but that's fine. You know, it's cool having follows, cool having people dropping in sometimes, learning a bit about distributed systems. I appreciate it. I appreciate the I want to say I appreciate the attention, just like the attention whorishness. But no, I just appreciate the fact that I'm doing something that's fun for other people. You know, that's nice. And I feel like I've gotten a lot of benefits out of streaming so far. I don't know. While I wait for this to finish, I guess I could chat about The traveling salesman problem, it's just something that's come up in an interview question that I was sent by a hedge fund over in Hammersmith. Solve the traveling salesman problem. I'll do that pretty soon. I was just thinking about how I'm going to do it. What's a nice way of doing it where I can learn something? And I think a way I like is to run the greedy algorithm. I should say, okay, traveling salesman problem is I have a bunch of nodes and they have distances between them. Calculate the shortest Hamilton cycle. Yeah, the shortest path that visits every node once, exactly. And the sum of the values on the edges, which are kind of like distances between the nodes in some interpretation, to minimize that. So it's a very difficult optimization problem. And the graph is complete because you can get from any location to any other location. It's just something getting from like Edinburgh to Penzance is pretty long, and you'll probably go through at least one other town, but that's accounted for by the fact that the shorter route will mean that you visit those towns on the way anyway. So it's without loss of generality to say that we're looking for a path that passes through every node once, because that node is kind of the official visit. It's not actually the only time we pass through that town, because we can calculate distances between any two nodes, including faraway nodes, whose optimal path would pass through other nodes, if you see what I mean. So I'm thinking I run the greedy algorithm, which finds the closest town at every step. I do that like from every starting position, because it's going to be towns in the UK. So I'm thinking I start from every possible town and run the greedy algorithm to get a cycle. So those are going to be decent. And then I run a genetic algorithm on that to try to basically crossbreed the best bits of all of these greedy paths, so that they're kind of greedy locally, but not globally. Because greedy algorithm will land you into problems when it comes to global optimization. And so the breeding should hopefully get around that. And the genetic algorithm is all about crossing bits at random from one and the other. It's like sex in it. As well as introducing just random mutations to see if they help, and iterating that a bit. And so I feel like that's a fun, maybe not necessarily theoretically optimal, but kind of a fun, intuitively cool way of figuring out this problem. So I think that's the solution I'm going to opt for. Alright, anyway, let's take a look. How many race conditions do we now have? Well, we have the same one here with follower line 21 and follower line 22. Scroll past that. And then everything else passes. Oh, we have another. Okay, we have another race condition here. So common 48, request vote 33 are clashing. So common 48 is another instance of voted for. This one is locked. And what was the other one that clashed? Request vote 33. Is this not within the lock by accident? Request vote 33 is term sync. Huh, that's a bit strange. So the clash is like... Let me just, click on them all and then save them so that they're all in tabs here. Common 48. Oh, I'm not reading this correctly, sorry. This is the call stack, my bad. Common 48 clashes with something else. It clashes with candidate 37. Sorry, I got confused. Candidate 37 is this. Okay, what's happening here is it's reading voted for. Yeah, it's reading voted for outside the lock. Ah, interesting. It should not be reading voted for outside the lock. It should be reading voted for somewhere else. Surely voted for is just like... Sorry, my breathing. Okay, I'm being a bit stupid here. So I made a mistake. As in, I didn't fix it completely. So voted for equals myself. I set that here, right? I have voted for myself. And then I scroll down. I am the candidates. I have the candidacy. I persist that. I look at args, last log term, whatever. I run a term sync, but I only run term syncs after I have sent out a single RPC, and I am not sending RPCs out anywhere until here, where I send out request vote, which means that at this step, my voted for this particular election is not going to have changed. So I can just ditch this line of code basically. It is possible for it to be changed by something else, but in that case, this thing should have lost its candidacy anyway because it was forced into being a follower by term sync, which don't forget is the only other thing that can change voted for. If we look at if we look at when to persist, voted for is edited by calling a new election. RPC term sync and when I vote for somebody else. So when I am told to vote for someone, that's when I handle a request to vote. In that case, my voted for is changed. But it's not going to be changed if my term is not changed and I voted for myself. I'm not going to vote for the other person, so I may as well preemptively vote for myself. Yep, works. Okay, good. Cool, I found another race condition. It's gone now. Are there any others? No. Okay, once again, let's just run go test with the race condition detector. Something I find really funny about this is that you can literally see only the first test even triggers this. I don't know how, but somehow. Only initial election is failing, which is hilarious. That's the easiest possible test. Fails because of that stupid, like, nonsense synchronous thing about something that is literally just about changing a timeout. And it changes the timeout in a monotonic way, as in the changes are always compatible with each other. It just continually overwrites it, one variable with another value, and it keeps overwriting it with the same value. The point is, it's only not that value at the very beginning. So yeah, nonsense. Okay, god damn it. This is going to take another 3 minutes, I just realized. Whatever. Yep, so I'm going to do that traveling salesman stuff hopefully soon. It's been 2 weeks since that company sent me that, but I just haven't had time to look at it because partly because of motivation, juggling everything in my life, and partly just because I had a busy week with just a lot of social stuff, and so I found it difficult to schedule this. I didn't really put myself under pressure to get it done fast because they didn't give me a deadline, which is a bit sketchy from me, but hopefully I'm going to be okay with that as long as I definitely finish it within a couple of days. Tomorrow and day after submission at the very latest. So yeah, cool. Yep. So I'm no longer accessing that shit outside the bloody outside the. I don't know. Part of me is thinking, why don't I just send votes true, and just do if ID is not me, don't send votes true, because then I can send a true vote like immediately, like right here, or I can even just ignore that vote totally. But nah, this code is very legible. That's why I'm happy to leave it as is. I always vote for myself, no matter what, because I set my voted for variable to be myself. So yeah, if this happens not in the same place in the code as this, which is bad, but it's not that bad because if this gets interrupted, that means that this thing shouldn't be running an election anyway, so it should be okay. We'll see how it goes. Thankfully, running the race condition test will automatically run all the other tests as well, except for the first one, because the first one fails anyway, because of the fake race condition. That is definitely not a race condition. I'm not accepting that. It's just some nonsense. There's just no reasonable explanation for why that's happening. And so, yeah, I can, if I want to, manually test the first test at the end. But, point is, I'll be able to run all the tests anyway with the race condition detector. Funny, I had a crap load of race conditions. I thought I didn't have any, but obviously you can't be too certain, and so it's good to. It's cool that Go provides tools for you to identify your race conditions. Yeah, in case anyone's dropped in and doesn't know what a race condition is, by the way, because I've used that word a million times, a phrase even. A race. It's when you have two concurrent routines, like two threads, that access a piece of data, write or edit the data. And what it is those two, do stuff to the data, but there's no way of predicting in which order those commands will execute because they're being run concurrently with no dependency between each other. And so you get around that by having locks, which, in your code, which guarantee a time when a thread picks up a log, or a function that is being run in a thread picks up a log, guarantees that there will be no edits to that data while the lock is in place, and then drops the lock afterwards. And so that means that because you know where you're picking up locks and things, are not going to run into this kind of, deadlocks and things that can happen if you just allow these edits to happen in any order. You still don't know what order they'll happen in, but like you don't run the risk of data corruption from two things literally editing at the same time, or that kind of stuff. It's just, I don't know, it's kind of intuitively obvious code safety. So let's have a look at the new race file. We have our race, and then we have all the other test passing. So again, it's the same thing. It's follow a line 21 and follow a line 22. I promise this is synchronous code. And it's telling me that, well, there was a read in line 21 and then a write to the same variable at line 22, which is just how synchronous code is supposed to work. I don't know if I'll ever fix that. But anyway, that's the race condition that's detected. That fails the initial election, but everything else reliably passing. Sick. Okay, excellent. And I can run that stupid test now. Initial election. That'll pick out the test one individually, and it won't pick out any of the others. I think, yeah. That's the correct test, right? Test initial election. That's the test that failed. Well, I just tested it. It succeeded. All good. That's it. That's all I care about. And that's it. I'm back. Gonna leave quickly. It's midnight 22. Gotta get some food, go to sleep, maybe play some video games. Or maybe get back to traveling salesman. I don't know. See how I feel. But yeah, back on Thursday at 9 p.m. and that's British Summer Time, UTC +1. For reference, that is 1 day and 21 hours minus 23 minutes from now. Easy, and by then I will have run my iterated stress test, which is literally just 200 rounds of Go test, the full tests in the order they're presented. And I will have outputs. If it succeeds, I'll have times, the time the tests took, the full set of tests, so it's about 3 minutes for the full suite of tests. And if it fails, I will get a log to read through to see why it failed. That's it. Thanks for chilling. If anyone was watching today, I appreciate it. And yeah, I'll see you guys next time. I'm just going to check. This is session 27, isn't it? 28 even. Yes, I'm just going to commit session 28, close up Visual Studio Code and this folder and all this stuff. And heads drifted down again. Without further ado, 2 hours and 40 minutes. Bit of a long thing.